Okay, good morning. So today, nothing that much is left from this topic, and this would be the last topic that I will teach and include it in the exam. There are some more topics that I haven't discussed here in this chapter. They will not be included in the exam. Okay? So calculating probabilities using integrals, I will teach them, but I will not include them in the exam. Okay, so in this this chapter, the topic will be in the applications of integrals for calculating areas and the volumes. Okay, that would be straightforward if we make it the topic of one exam. So there is one thing in the book which is new to this book. It was not in the other books. Let me also talk about that one. So that actually this volume, calculating volume starts with this. But that is essentially the same thing, more or less. But the drawing, the pictures are a little bit hard, but let me try to do my best. So assume that you have so far we had an area and we rotate it about the x-axis and we generate a volume, yes? But now that the volume from the beginning is given to you and you want to find the volume of that object, yeah, a solid object is given to you and then you want to find the volume of that one. So one way to do it, so let me just try to, if I can, try to draw something to illuminate this. So assume that this is x and y axis, and actually the z axis, the third dimension, is coming out from the whiteboard, okay? And then you have your volume somewhere on the board which is coming outside. For example, if you assume a sphere I cannot embed a sphere on the plane because it's a three-dimensional object, yes? So assume that you have a volume. So I will try to draw something here for you if I can. But, so yeah, consider this to be a volume, yes? Yeah, the cross-section, I don't know how to draw other cross-sections, but that is actually important. The cross-section, the form of the cross-section doesn't matter. It might be a circle, it might be an ellipse, it might be an irregular shape, whatever it is. That's important. But by cross-section, I mean you take a plane perpendicular to the x-axis, this is important, and then you cut your volume with that plane. And then you get an intersection there. Depending on the form of the volume, that cross-section might have different shapes. For example, if you have a cube and you cut it with a plane, the cross-section is again a square. Yes, the perpendicular cross-section. I don't know, if you have a cone and you cut it, what would be the cross-section? Circle. A circle. I don't know, a sphere, the cross-section would be a circle again. But if I have a very irregular solid object, a three-dimensional object, it might happen that when I cut it, it's a different. Of course, it might happen, even it might be different. For example, I don't know, you can imagine that you glue a cube to a cone, and some parts, the cross-sections are squares, and when you go to the cone section, the cross-section becomes, the circle. So I mean that this volume in principle could be very general, yes? So the point is this. If you want to calculate the volume, you can also do this. You have your volume, you go x units forward, for example, and then you take the plane perpendicular to the x-axis, x from the origin, and cut your volume. Assume that the area of that cross-section is A, yes? But of course, this area is not fixed. Even in this poor figure, you can realize that, for example, if I make x smaller and I do the same thing, I will get another area. Yes, this area is different from that area in general. So it means that this area of the cross-section of the perpendicular cross-section depends on x. Yes? And then it turns out that if you integrate this cross-section dx from the starting point, say let A, B, this will give you the volume of that object. Yes? And this is not hard to understand intuitively, because delta x is just, so let us understand it a little bit. So instead of looking at one cross-section, let us see, as usual, that is common for integration, let us consider a thin layer. Instead of one cross-section exactly, let us consider a very thin layer. I don't know how to draw it, but so hopefully you understand what it means. Okay. And this thickness is delta x. So if I take this thickness and multiply it by this area, the area of the cross-section, this gives you the volume of that very thin shape here. In this case, a thin disk. So this one is the volume of this thin disk, and I integrate. It means that I add these layers after one after the other. So this gives me the volume. Yes. So ax dx is the area here multiplied by the thickness, which gives you the area of this shape, whatever it is. Sorry, the volume of this shape, whatever it is, approximately. And then, as usual, if I make dx very small, this becomes closer to reality, closer to the real volume. And then integral means adding these numbers. In this case, this number is the volume of this part. I do it for the next portion, I do it for the next portion, and then integral means adding them up. So intuitively, it is not hard to see that this will give you the volume. Usually this is in more advanced texts, so in the book they have chosen to talk about this one as well. Okay, and then there are some problems in the book, I will discuss about them as well. So, for example, let me give you an example, it's not hard at all. Do you remember we were able to calculate the volume of the cone from the method that I told you by revolution, by rotating, for example, a line about the x-axis making a cone. Now let us assume that the cone is given to you from the beginning, yes? So assume that they have given you this. Something like that. This should be completely symmetric, of course. So let me put this dotted line. Okay, so you want to calculate the volume. I give you the height is h, radius is r. So let me make it h and r. So you want to calculate the volume of this cone. So, and the height is given, the radius r is also given, using this method. Okay? So you see, you remember, in the previous method, you need to imagine a graph so that after being rotated, generates the volume. But now the volume itself is given to you from the beginning, and you're supposed to find the volume. So what I am supposed to do, I told you that. You go x units forward. Yes. And then cut it with the perpendicular, with a plane that is perpendicular to the x-axis, and look at the cross-section. I hope that you agree with me. The cross-section would be another, yes, another circle. And then your goal is to calculate the area of this cross-section. Okay? But as a function of x. So what is that? Can you tell me? If I want to find the area of this, I need to know the radius of this, because this is a circle. It turns out to be a circle for the cone. And then I want to find the radius of this circle in order to be able to write the area. So it means that I am interested to find the radius. If I can find the radius of this cross-section, so let me call it little r, then I will be able to find the area of this cross-section. Yes? Okay, how can I do that? So you need to know a little bit of geometry from Math 2C, yes? from here to here is h. From here to here, I have assumed that to be x. And then you know from here to here is the radius of the cone, which is r. So I hope that you agree with me that these two triangles, this triangle and the bigger one, are similar. If they are similar, what can I write? I can write the ratio of r to r is equal to the ratio of x over what? H, capital H. And then from here, H and R, capital H and capital R are given to you. So you need to find X. You need to find R because you want to find the area of the cross section. So little r becomes R over H times X. Yes? So that is the radius of this smaller circle as a function of X. And that is reasonable because if I change X, this circle becomes bigger or smaller. So the radius is actually a function of x, depends on x. Okay, what is the area now? Area of that cross section is a circle, so it is pi r squared. But r is this expression, so this becomes pi r over h x squared, which becomes pi r squared h squared x squared. Yes? And now, according to this formula, I want to calculate the volume. In the book, they have used letter V here, probably because of a Swedish word. But I use A, okay? So, V becomes integral from where to where in this case? X, for this volume, X starts from 0 and goes up to this H. So it goes from 0 to h, and then I have to write this expression a of x, which is pi r squared h squared x squared, and then dx. Yes? And then what happens, this part is just a simple constant. I pull it out, and the primitive function for x squared is x cubed divided by 3. This becomes pi r squared over h squared, and then I have x cubed divided by 3, but I have to run it from 0 to h. Okay, so I put h and I put 0, 0 vanishes, so I put just h, so it becomes pi r squared h cubed divided by 3. Then I can simplify this h cubed with h squared, and I write it more simply as this. And that is the famous formula for the volume of the cone. Yes? But you really didn't need that much, so that's up to you. There are some exercises that you have to use this formula because I see some exercises in the book, they haven't given you the volume at all. They have given you a of x. So they say that assume that there is a volume for which a of x is this, follows this formula. For example, they say that, okay, we don't know the volume, even you don't need to imagine the volume, but they just give you the area of the cross-section as a formula of x, for example, like this. And they ask you to calculate the volume. So there is no imagination going on here. You have to know this to be able to calculate the volume for that. So there are some exercises that you really have to know this. The exercises, I will give you an example from the book. But before that, let me try to calculate the volume of a sphere in this way so that you get more experience of how to use this. Okay? Is there any question here? So in this method, whatever your volume is, okay, it doesn't matter actually where in a space it is located, but the point is that if I locate it in a wrong way, then I will make life harder for myself. For example, if I take this cone and put it like this here, then when I want to calculate the area of the cross section, I have to cut it with a plane perpendicular to x, but because this is tilted, then probably you will get an ellipse like, and then calculating the area of that ellipse becomes hard. It doesn't mean that you cannot do that, but you are making life harder for yourself. So here you also need to be a little bit smart to choose the appropriate orientation for your object to be able to calculate that. But in principle, that's not an obligation in general. Okay, So now let us go to calculate, to get more experience. I don't think you will get any questions in the national exam that you have to use this, because for example in the Origo book and Math 5000 I don't see this. So it means that this is probably not a standard, okay? But it is good to know because it is not for the interested student part. It starts with this, so let us know about it. Okay, can you help me now to calculate, for example, the volume of a sphere, for example, of radius capital R, yes? So I have a sphere, radius capital R, so let me just imagine. Again, you can make life harder for yourself, put the sphere here, but let us put the sphere at the center, yes? In the book, I don't know, for some reason they have put the sphere here, okay? So you can just see that, but we can also solve that one. But let me just stick to this very intuitive idea that I would put my sphere somewhere here, yes? So this is a three-dimensional object, so let me just try to give you the idea. Okay, so that's the sphere. And let us consider that the radius is r, so it means that this point is negative r and this point is positive r, yes? The third dimension z-axis is coming out from the plane. Okay, let us understand how is it going. If I want to calculate the volume of this sphere, using that formula, what I need, I have to go x units forward, for example, and then cut my sphere, and then take a plane which is perpendicular to the x-axis and passes exactly through this point, and cut my sphere using that plane. So what will be the cross-section? The cross-section becomes, hopefully you understand it becomes a circle again, yes? So if I cut it, so let me, I don't know how can I draw it. I don't know, something like this. So in principle, this should be dotted line if I want to. Something like this. And then this should be a solid line because I can see it. This goes back to the sphere, so I cannot see it. Something like this, hopefully you understand that. Okay, now I want to calculate the area of the cross-section, which I call it A of x. But, as I told you, I need to express it as a function of x, which is not surprising because when I change x, this location of this cross-section will go forward or backward, and then the radius will change, so the area will change. Okay, now can you help me to find the area of this hatched circle in terms of x? So how can I do that? So what are you looking for? You need to look for the radius of this circle in terms of what you have. You only have the radius of the sphere. And then you also have x. You can pretend that I have x because I want to write the area in terms of x. Okay, so what can I do? It's even simpler, I think, than the code. So let me just draw for you. You want to find this radius. You want to call it r. And then from here to here is how much is x. You want to find r in terms of x. What does it mean? It means that you want to find the formula so that when I give you x, you can use your formula to find r. It's very, very simple, isn't it? Yes?
Capital R minus y of x, or f of x.
No, there's no f of x here. There's no function here. Be careful. In the previous perspective, I gave you, so you have to generate the sphere by imagining a two-dimensional curve so that after being rotated generate the volume that you are interested in. But this volume is already given to you. Yeah? So you put your sphere here and you want to find its volume. So let me give you a hint. So what is that? That from here to here, what is that?
1.
No, not 1. This is the R, yes? So that's very simple actually. So from here to here, I told you, I cannot ask you to calculate the volume of the sphere without giving you R. So I hope that you agree from the center of the sphere to any point on the sphere, the distance is R, yes? And this is a right angle triangle, so you can write Pythagoras theorem, yes? So you can write R squared, capital R squared, is equal to R squared plus X squared. I told you, you are looking for R squared, so R squared becomes R squared minus X squared. Yes? And now the area of the cross section, is pi R squared. So this becomes pi. Instead of R squared, I put this. So that is your formula. I was supposed to find the area of A in terms of X, and I did it. So what I need now is to use this integral from, okay, so let me write it. A of X is this guy. So let me write the formula here. Okay, so this becomes integral. Instead of A of X, I put this formula I got. But I should go from where to where? X in this volume changes from here up to here. Here is minus R, here is R. So I have to run X from minus R to R. Yes? And if I calculate this, hopefully it will give me the volume of the sphere if you haven't done any mistakes. But of course pi is a constant, I pull it out. A primitive function for this constant is R squared X. A primitive function for X squared is X cubed divided by 3. And then you have to run it from minus R to R. Again, I could run it from 0 to R and then multiply it by 2. Yes? Because if I run it from 0 to R, it gives me the volume of the hemisphere. And then I multiply it by 2. Okay, let us just do this one. So what I have to do, I split it into 2 parts. I put R here, so this becomes pi R cubed minus R cubed divided by 3, which is 2/3 pi R3. And I put minus R3 there. So minus R there, it becomes minus R cubed plus R cubed divided by 3. This becomes negative 2/3 pi R cubed. Then I go back to horizontal, subtract these numbers. And that is what you expect for the volume of this sphere. So I think it's good to know about this, and let me solve one of the problems in the book that you have to know this formula, okay? So let me find it out. Okay, so let me, for example, solve this problem.
Baba,
Yes?
so the point is that we are calculating the sphere, but with the help of the cross section.
Yes. We calculate the volume.
It's not another volume. It's the volume of the sphere.
Yeah. You calculate the volume of the three-dimensional object given to you, but the method is to slice it, and then every time calculate the area of the cross-section and integrate it. This will give you the volume of that object. Yes? Okay. So for example, there are some examples, as I told you in the book, that you have to know this formula. The previous method doesn't work. In this case, you could also use the previous method to solve it, okay? So these problems are artificial problems because usually we are interested to see the volume in front of us and then try to calculate the volume. But this one is giving you a formula for the cross-section, even if it's not easy at all to imagine what would be that volume whose cross-section is following this formula. Yeah, so that's artificial problem, so that's what I don't like it. But anyway, it's in the book, so let us just do that. So here, I don't know, for example, we can solve problem 5075 from the book. Exponent 4, yes? Of course, this is the hard copy. I think the numbers are more or less the same. I have seen deviations from that. So they have talked about you have it, I don't know, three-dimensional object so that the cross-section, the perpendicular cross-section of that object follows this formula, you know. And I don't know why they have this time used the function f of x. And then you are supposed to determine the volume. So you see, this is probably an artificial, I think you can, I don't know, might be you can generate somehow by coding and visualizing. You can draw a shape, a three-dimensional object, so that its cross-section from 0 to 1 follows this rule. It's not easy at all, okay? But anyway, if the cross-section formula is given, this f of x is playing the role of a of x. If you read the text, they will tell you that this is the area of the cross-section perpendicular to the x-axis. And then you are supposed to find the volume. So in this problem, there is only one option, and that is using that formula. So the previous method doesn't work. Okay? So what you do, you can just write the volume is integral, just simply just put the function in, yes? Yes? And then calculate this integral. Yeah, then what should I do? I pull 1 over 6 out. I multiply x in, and then I integrate. But these primitive functions are very simple. So by the way, be careful, there are no pi involved in this formula. Yes? If there is a pi, it will appear in this area formula. So you see that in the previous formulas, do you remember what was the formulas? Pi integral f of x squared dx and pi. Yes? This pi, you have to put it by hand here, but there are no pi's here. If there is going to be a pi, the pi will appear when you want to actually calculate the area. Okay. If I want to calculate this, it becomes x to the power of 3 divided by 3 plus x to the power of 2 divided by 2. I have to run it from 0 to 1. So it becomes 1 over 6. I put 1 here. It becomes 1 over 3 plus 1 over 2. It becomes 5 over 36 volume units. Yes? I don't need to put 0 because it becomes 5. Let me double check these numbers. I hope that I could translate it correctly. So 550, 75. Yes. Yes, that's correct. Okay, now I realize, can you find this formula using this idea? I just want you to see that they are really connected. Yes? I don't know if you remember how I motivated you about this by slicing that. So here, let me see if you can tell me. Assume that I have given you that formula first, and then I ask you to calculate to find this formula. Can you do that? Let me clean this. Do you remember what was this formula? What was the setup for this formula? We had actually a function y equals to f of x. There are no volumes involved yet. But then I will take this area and rotate it about the x-axis. Then I will generate a volume. Yes? So you will generate a volume. Yes, something like that. Something like this. So then you generate this volume. Yes? How can I use that formula to find this formula for the volume? If I give you this volume from the beginning and ask you to find this volume using that formula, what you are supposed to do?
Choose an x.
Choose an x. You just take, for example, x here, and then cut it with a plane perpendicular to the x-axis. But that would be definitely a circle, no shape else, yes? Because I start rotating it about the x-axis, so there is only one shape for the cross-section, and that is definitely the circle. Is that clear? In this case. Okay, so it means that I go here, and then I will actually draw that. So then I need to find the area of this one. But the area is very simple now. You see, what is the radius now? F of x. Yes? And then you want to find the area. So the area is pi, the radius to power 2. Yes? This is a of x. And then you put it in that formula, you get this formula. Yeah, so that's exactly connected. Yeah, so that's not something very strange. Okay, so that is also good to know about the connection. There was a problem I wanted to solve for the previous group. I messed up. I don't know, probably I was tired. It was a level 1 problem, but when I started calculating it, so I don't think it deserves to be an A-level problem. Yes, let me ask you to see what is your opinion about how to solve. I will solve 2 problems. I missed both of them actually. I messed up because one of them, my eyes didn't detect the number correctly, and the second one I really messed up. Okay, so I just want to solve those problems because I promise I will solve the problem and upload it. Because immediately after the lesson was finalized, I realized what was my mistake. Okay? But then it was late. People have gone, yes? Okay, but let me try to solve those problems. But I want you to do it for me first. Yes? And I really hope that you mess as well. You mess up as well, yes? Otherwise I would be very jealous, yes? Yeah? Okay, so this is problem 5090. Be careful, don't make my mistake. Just have you have your picture because it's hard to draw it carefully, and that was one reason that I messed it up. So the problem is 5090, and let me see if I can see it again. So we have a graph. I will try to draw it here for you. So this point, this graph is y equals to e to power x. Yes? Okay, and then here is given, so the grids are 0.5, that was my mistake. So this is given to be -1. Yes? So this is 0.5, and then this is -1, and then, yeah, this is here. So let me try to draw it carefully this time. So this is 0, this is 1. Yes. Yeah, that was the graph. And then this area, okay, and then this is given to be 1. This is given to be -1. This is given to be -. That's correct. They have, and then this line is y equals to -2. Okay, the reason that I messed up is because scalings are different. I didn't care about that when I wanted to solve. So it's better to have the picture in front of you if you want to solve it. And the point is that if I rotate this area, not about the x-axis, if I rotate this area about this horizontal axis, what will be the volume? Yes, we talked about rotating an area about a different axis, a horizontal axis. But the reason that I messed it up is because in the picture, the scaling on the y-axis and the scaling of the x-axis are different. I didn't notice that in the beginning. Okay, so please put the picture in front of you and try to solve that one. And the number is a very, very bad number. Keep it exact. Then I use GeoGebra to see if the answer in the book is the one that we are supposed to get. Because in the book they have given the approximate value without mentioning that. If they want you to write approximate value, they have to mention it in the problem itself. Otherwise, you have to keep it exact. Okay? So please do not trust or rely on my drawing. This is problem 5090 in the book Exponent 4. Yes? I will pause recording and I want to wait for you. By the way, people at home, you can go to problem 5090 because when I pause recording, you will not be able to see the drawing. And you don't lose anything but not see my drawing, of course. Okay, if you don't mind, let us start solving the problems because there are some nice problems. I want to solve most of them for you. Okay. So could you solve this problem? At least you need to set up the integral. Calculating the integral is not the major problem here. Hopefully you have learned how to calculate simple integrals by this time. The only important point is to set up the correct integral for the volume you're supposed to calculate. So what is that volume? So what is that integral? So for the time being, I really recommend you forget about this formula that we learned today. Just go back to the previous formula. So most of the time we calculate using them. So what should I do? Can you tell me? So do you remember I solved? So you need to imagine from scratch. I really recommend you to do that. Okay. So take one line here. So with a very thin thickness. Okay. I just intentionally want to write something like that. Okay. So this is the way you need to think. So assume that this is a very, very thin rectangle, okay, where this is x. Yes? And if you rotate this thin rectangle about this axis, imagine what it will generate. What it will generate. You can consider it a thin line, yes? A line, not a thin line. The line doesn't have any thickness, yes? So what it will generate, it generates a circle, yes? And then you can think in this way. This is a really helpful. Of course, it might be a little bit harder, but the good point is that you don't mess things up. So call the volume of that thin disk dV. And then imagine what is the, so you need to have this in your memory. What is the formula for the volume of a cylinder or a thin disk? Is pi, its radius squared, its thickness, the height. Okay, so I will write pi, and the thickness is just dx. A small change in x is the thickness of this. But the only thing that you need to know is the radius squared. So I hope that you agree with me. The whole blue line will play the role of the radius of that.
Yes.
So, but what is the length of this? Can you tell me? What is the length of this blue?
E of x plus 2.
Pardon?
E of x plus 2.
Yes. E of x plus 2. So you see, if you understand it, you will never make mistakes. Yes? So from here to here, I really don't need to say anything. It is clear this is 2 units. Yes? And from here to here, because this is on this from here to here, and this is x, so this is e to power x. So you don't get confused, even though this is negative, but you need to write e to power x plus 2, because you want to find the total length. So if you visualize it, you will never make mistakes. So then what happens, this is your radius, so it becomes e to the power of x plus 2, but you need radius squared. And that's it. I really want you to understand what you are doing. This trick, you will really need it in the future to write a very small part of the quantity that you want to calculate and add them up. That's the meaning of integral, yes? So then you want to calculate the volume. The volume means the integral of this expression. But x goes from where to where? That was my mistake. It goes from -1 up to 3 over 2, yes. And then pi goes out, and then this 1 is squared. So if you have set up this integral correctly, it means that you have learned this lesson. I don't know how many of you could write this integral. If you have already written this integral, it means that you really understand what's going on. Yes? And then let us calculate this integral quickly. Now tell me, how should I calculate this integral? How should I calculate this integral? I have to expand, yes, because we don't have any rule for that. I have to expand. So this becomes -1 to 3 over 2. I expand it e to power 2x, 2 times the first one times the second one, and the second one is squared dx. And these are very standard integrals, so it becomes 1 over 2 e to power 2x plus 4 e to power x plus x. I have to run it from -1 to 3 over 2. Yes? So then I put pi, I put 3 over 2 here, it becomes 1 over 2 e to power 3, and then I will have 4 e to power 3 half, and then I have 3 over 2. And I put -1, so it becomes 1 over 2 e to the power of -2. Yes?
You wrote +1 for e to the power x plus 1. This is supposed to be +4.
Plus? Yes, thank you very much. Thank you. So this is 4x, yes? Am I right now?
Yes.
Yeah, that's 4. Thank you very much. Otherwise, I would have missed it once more. So this becomes, so it is easier now. 4 times 3 over 2 is 6. Thank you. And then I put -1 there. It becomes -4. Yeah, please be observant if I am making any mistakes. Yes, that's correct. Yes? Everything seems right. And then I have to subtract them. Okay? So when I subtract them, there's a pi in common. I write this minus that one. -4 and 6 becomes 10. So it becomes 1 over 2 e to the power of 3 plus 4 e to the power of 3 over 2. And then minus 1 over 2 e to the power of -2 minus 4 e to the power of -1 plus 10. So this is your number. This is the volume. Double check. Yes, that's correct. But then I don't know. I have to put this number in GeoGebra to see if that is because the book, the answer is 114 something. Yes, let me see. 5090. Yes, they have given 114 volume units. So if you don't mind, let me just do that.
Always so satisfying.
Okay, so let me at least set up this integral. The reason is that because it was in the level 1 problems, I thought that I can just naively use the formula in the book without thinking about if I am writing the correct integral, and it turns out to be wrong. The next problem is this. So it is really essential to think in this way to be able to find the correct integral. You're supposed to calculate the volume of a rotation of this curve. You have a curve. So this is given to you. Okay, let me make it proper. So the problem is this. You have an area which is bounded. No, they have written in this way. You have an area which is represented by this double inequality. This is the first time you see something like this. Usually they give you the area with equations. And then you are supposed to rotate it about y equals to 1, not the x-axis. Yes? And then you want to find the volume. Yes, let us do it together because there will be no time if I want to solve one more problem for you. So first of all, let us understand this. So this is my coordinate system. Y equals to 0 is clear. That is the x-axis, yes? This is y equals to 0. Y equals to 1 minus x squared, I don't think you have any problems understanding that, yes? Because this is x squared. If you say minus x squared, you need to flip it over. This is minus x squared. And then you shifted 1 unit up, yes? So that is just this function. Yes, so this is 1. And I hope that you agree with me. Here is minus 1, here is 1. Why? Because if I put it equal to 0 to find the intersection with the x-axis, I will get minus 1 and 1. And then y between 0 and 1 minus x squared means this region. Above y equals to 0, greater than 0, but smaller than this. So this means that this is the region that you're supposed to calculate. So, sorry. You rotate it not about the x-axis, you rotate this region about y equals to 1. Okay, so let me just draw this line. This is y equals to 1. And you want to find the volume. If I rotate this hatched area about the green line. So how can I calculate the area? Sorry, how can I calculate the volume?
Då kan man väl använda den här formeln. Man kan väl använda den här formeln.
Alltså man måste använda.
Ja men använd bara f av x och sen just
Det är han alltså vi måste använda area. Va? Alltså innan.
Det blir en konstig...
Det blir en sfär. En sfär med typ sån här. Det blir sliter. Nej. Det är sån här. Som har din sfär.
The reason actually I make it wrong because I saw that this is a level 1 problem and there is a formula in the book that if you rotate it about y equals to k, they have mentioned this is the formula.
Oh my god.
And I don't think they have mentioned any exceptions for that, and I naively actually use the formula in the book. They have written that if you rotate the area about y equals to k, and if you want to find the volume, this is the formula. It is not wrong. This formula would have worked for the previous case. But the point is that this formula works if the total area is above the axis that you want to rotate about. So this, they haven't mentioned, if I understand it correctly. You can check it yourself, but I don't think they have mentioned this. Yes? So this formula is not generic. I naively just simply without thinking, because I thought that this level 1 problem, let us use the formula. Okay, this formula does not work for here. Because if you were supposed to rotate this about this line, it would work. Yes? But now you want to rotate it about y equals to 1. So we really don't think this is a level 1 problem, because you need to imagine how to do that. There are two ways of doing it. One way is to start writing an integral. I want you to understand this because that's a good practice. But there is a simpler way for that. Okay? Let us do the harder one first. The harder one is to understand the problem. So what I'm supposed to do, I go x units forward and I look at this thin rectangle. Yes? Thin rectangle, you can imagine it's just a line. It's a thin rectangle. And you start rotating, be careful, you start rotating it about the y equals to 1. Can you imagine what it will generate? Not exactly a cylinder. It's called washer. Yes? Washer is exactly like this, I don't know, rubber plastic bands that you put not to prevent leakage of water. Have you seen that? The black ones. Oh, forget about it, okay? So the washer is something, a cylinder which is the middle part is carved out. Yes? So can you imagine? Because let me just tell you here. If this is my line, and this is the line, if I start rotating it like this, of course it will generate a full circle. Yes? But if I keep it a little bit higher, and I want to keep this distance the same all the way around, it will not generate a circle. It will generate a rim of a circle. Yes? So this is important. So if you want to understand what is going on, I hope that you agree with me, it will generate something like this. Yes? Is that understandable if I rotate this about this? And now, if I ask you what is the volume of this part, this I want you to learn. So what is the volume of this one? Because this would be volume if this is a little bit thick. Yes? So the volume of this, can you tell me what is this one? So here I have one radius, let me call it R. And I have another radius, let me call it R. So you want to find the volume of your object. So what I'm supposed to do, I am supposed to calculate the volume of the bigger cylinder, which is what? This is the volume of the bigger cylinder, yes? Minus the volume of the smaller cylinder. Is that understandable?
Yes.
That will give me the volume of this shape. Is that clear?
Yes, yes.
So this thickness plays the role of the height. So and that is the formula. So this means that this becomes pi r squared minus r squared dx. This is the volume that I have to add up using integral. But can you tell me what is capital R and little r in this setup? What is the little r? Can you tell me what is the little r? Or what is the capital R? Capital R is very simple. Capital R is 1, yes? Can you imagine capital R is from here to here, which is 1 unit. So this becomes pi 1 to power 2. But can you tell me what is the little r? Little r is this distance. Do you agree with me? If you rotate, that is the little r. And what is that distance now? What is the distance here? So this plays the role of the little r. What is this distance? 1 minus the blue line. But what is the blue line? 1 minus x squared. Yes? Is that understandable? So then it becomes x squared. Yes or no? Is that understandable?
Yes.
Okay. So you see from here, this distance is from here to here, which is 1 unit, minus the blue line.
Yes.
But the length of the blue line, because this is x and the function is this, so the blue line is 1 minus x squared. So if I subtract them, it becomes x squared.
Okay.
And then I put it here. So this becomes x squared, but this is r squared, so it becomes another square. Yes? And then what is the answer? Is pi 1 minus x to the 4 dx. Actually, this is a very simple integral to calculate, but hard to reach to it, you know. If you naively use, as I did before, put k here equals to 1, you will not get that integral. What do you get? You get y minus x squared minus 1, and then squared. And then this one and that one cancel. You only get x to the 4, which is not correct. You have to write 1 minus x to the 4. And then let us integrate. So the volume becomes integral from where to where? From -1 to 1. X goes from -1 to 1. And then this expression, pi goes out, and then I have this one. And then what do you do? So this becomes x, and this becomes x to the power of 5 divided by 5. It goes from -1 to 1. Then you put pi. This becomes, it becomes 4 pi over 5. This becomes minus 4 pi over 5. If you subtract them, volume units. And that's exactly the correct answer. Okay. So if you want to look at the problem in this way, I would consider the level 3 problem probably, because you need to have a good imagination. But you can solve it easier, because you don't have to force yourself to calculate using the setup in the problem. Your goal is to find the volume. So if you just want to answer this for the volume, what do you suggest? It's simpler than doing it like this. Can you solve this problem simpler?
If you rotate it around the x-axis, will it generate the same volume?
No. Does it? I don't think so. Because, I don't know, you need to imagine, if you rotate this part around the x-axis, it is something similar to a sphere, not a sphere, similar, yes? Something like that, yes? But if you rotate it about that, it will, I don't know, you need to imagine, this gives you a different object, yes?
Yeah, it gives,
but I don't know, if that's a different object, then if you want to show that the volumes are the same, you have to prove them. That trouble becomes harder. But you don't need to work with the setup. You can shift it up and down. Yes, because the volume will not change by shifting it up and down. Yes.
Is that what she said?
I don't know. I might be. If that's what you said, probably I understood you wrong. But I shift the whole thing down.
Yeah.
Not I rotate this. So what you said, I understood it in this way, that you want to say that I rotate this region about the x-axis. So I'm not doing that. What I am doing, I will shift everything 1 unit down. Yes? So then what happens, so what can I say? So this will go here. Yes? And this will start from here. But I will keep the limits the same. Yes? And then I will rotate this area about the x-axis. Yes? Is that understandable? So I shift everything. But this is a standard. Do you remember I gave you another formula? I told you that if you have two functions, one of them f of x, one of them g of x, and if you want to rotate the area between two functions about the x-axis, then the formula is this. Yes? So now, using this, I can write the integral again by imagining that I shift it down, yes? So what is that? So I shift it 1 unit down, so then I will take this region. Still, I keep the same region, be careful. I shifted 1 unit down, I take this region, shifted 1 unit down, and then this graph is one function and this graph is another function. and I have the area between these two, but still I rotate about the x-axis. So this is your standard formula now. So if I use that, it becomes pi integral from -1 to 1. The function above is which function?
1 minus 6.
The function above is, no, you have shifted this function down. So this is no longer that function. This function is just this function. Yes? Do you agree with me? Because I have shifted this function down, the formula of the function will change. Yes? The graph of this function is of course the same shape, but shifted 1 unit down. So the equation will not be the same. I have to subtract 1 from it. So it is minus x squared, but I have another squared. Yes? And then what function is below?
Is it minus 1?
-1. So it becomes -1 squared dx. This is another way to see the problem. But now let us see -1 to power 2. It becomes +1. This is minus x squared to power 2. Yes? This is -1, sorry. There's -1 to power 2. There is another minus sign. It's -1. And this becomes positive x to the 4. Yes? Is that the same integral or not? With the minus sign difference. Why? Do you see why? Because this should be 1 minus x4. What I have got is x4 minus 1. Do you see my mistake somewhere? Because when I bring it down, this is the function above. Yes? I don't see what I have done mistakes there. Are there? And might be that is the reason we haven't done any mistakes. Might be this is because everything is below the x-axis. We have to multiply by a minus sign. I have to think about it properly. To be honest, finding the volumes always you have to do this analysis. Otherwise, it is not very clear that you might make mistakes. Might be if I do this analysis using this again, I will get it the other way around. But I don't see any problems here.
Vänta, det första så går vi från 0 till x. Och den andra går till minus x. Det är kanske det som gör, om man räknar ut själva integralen kanske liksom ska vara till x. För vi har ju gått ner. Jag har gått ner men inte går ut fortfarande. Det första är dina x-värden 0 och 1. I den andra är minus 1 och 1.
Är det 0 och 1? Kolla här. Var är det 0 och 1?
Okay, now I understand what's the problem. The problem is, if this area goes below the x-axis, might be I have to interchange them.
Why do you have to interchange?
Okay, let us understand. This is why I'm saying, when you go to university, you really don't just memorize the formulas. You have to have this analysis for each problem. But for very standard problems, even if you don't do the analysis, it will turn out correctly. But let us see. So that was even, I am just learning right now probably, okay? So if I take this function and put it here, this function is above. Yes? And then this function is below. Okay? And then what is happening, if I want to find the volume, so even I need to think about this thickness, So this volume, if I rotate it, this will generate the bigger volume. Yes?
Yeah.
Do you understand that? That was my mistake. When I was teaching you this, I told you that this is the formula. This is correct for this setup. Yes? Even if this part is below, this will work. Even for this case, this will also work, but this is meaningless if you want to rotate it about. So forget about this. But if this whole area is below the x-axis, according to this analysis, you really have to write g of x first, not f of x. Because when you rotate this, even though this is the lower function, yes, but this will generate the bigger volume so that you want to subtract the previous one. So in this setup, I have to start from the other way around, yes? So if I want to write the correct formula for this setup, I have to write this. I have to start with this one, which is lower, minus that one, which is higher. And then I get exactly this integral. Yes, so that is, I learned this right now, be careful. I was careless. What I drew was correct, it was not wrong. And if the total one goes below the x-axis, we have to switch these two. Yes? Is that understandable? Okay, so that is why if you solve one problem from different perspectives, it will teach you a lot actually. Okay, so I already solved the... So there are some nice problems. Might be we can also spend time on Friday to solve some of these problems. Okay, so there are good problems. And then this part is only for interested students that I will skip. Okay. And then we have to decide about the exam time, by the way. So let me just pause recording the video. Thank you.